The major products resulting from petroleum refining are liquid petroleum gas, gasoline, naphtha, kerosene, diesel fuels, fuel oils, lubricating oils, paraffin wax, bitumen, and petroleum coke. These products are then used in our everyday lives, such as powering our cars. Crude oil, or petroleum, is a flammable liquid consisting of a complex mixture of hydrocarbons of various molecular weights that is found in geological formations beneath the surface of the Earth. Essentially, petroleum is the compressed, superheated remains of animals that died millions of years ago. Yet this fossil fuel is essential to sustaining our society and our industry. Geologists can use a variety of different methods to locate oil even when it resides deep beneath the Earth's surface. The most common method of locating oil is via seismic survey. Essentially, geologists use a variety of different tools to emit sound waves, which then delve into the Earth's crust, some of which bounce back to the surface. A computer can then interpret these sound waves and create a detailed three-dimensional image of the various geological formations beneath the surface, thus providing the approximate location and amount of oil in any given oil reservoir. If the oil is worth extracting, we then go on to the next stage of the petroleum industry.
When we drill, we are careful to protect the surrounding area, including groundwater. We install multiple layers of steel pipe, also called casing, and cement around each layer of pipe. This is designed to isolate the gas and fluids in the well from the potable water table or drinkable water. We typically drill several kilometers or more than a mile deep beneath the earth to reach the trapped hydrocarbon formation. Then, to access gas or oil locked in shale rock, we drill horizontally. We fire carefully calibrated charges that perforate the well casing and connect the well to the tight sand or shale rock layer. We inject a mix of fluids under pressure, mostly water, with sand and chemicals to create fractures in the surrounding shale rock or tight sand layer. The sand props open the cracks and allows the gas or oil to better flow into the well. We fracture the well in segments or stages. After each stage, we put in a temporary plug to separate the fracture stages and prevent gas or oil from flowing too soon. When we are ready, we drill out the plugs. This allows the gas or oil to flow into the well.
First, the conductor pipe is installed. As the drill pipes are connected, the conductor pipe and guide are run down to the seafloor. After the conductor pipe penetrates the seafloor, the drill pipe is released and pulled back to the vessel. A large drill bit connected to the bottom of the drill pipe is run down to the seafloor. The drill bit is led down to the bottom of the hole through the conductor pipe. The drill bit rotates and drills the sediment and rock below the seabed. Seawater is sprayed from nozzles on the drill bit to raise the cuttings to the seafloor. After drilling several hundred meters, the drill bit is pulled back to the vessel. A casing pipe, about 50 centimeters in diameter, is set into the drilled hole to keep it from collapsing. The casing pipe is run down through the conductor pipe and is inserted into the hole using the drill pipe. Cement is pumped into the space between the hole and the casing pipe to fix the pipe in place. After cementing, the drill pipe is released and pulled back to the vessel. The vessel is now connected to the seafloor via the riser pipe. A drill bit, smaller than the one first used, is run down through the riser pipe and casing pipe. The drilling begins. Once the riser pipe has been connected, drilling mud is used instead of seawater. When the target depth is reached, the drill bit is pulled back to the vessel. To drill the hole even deeper, a narrower casing pipe is set in to protect the drilled hole. After the casing pipe has been installed, cement is pumped into the space between the hole and the casing pipe to fix the pipe in place. Again, an even smaller drill bit is run down through the riser pipe and casing pipe, and the drilling continues.
The fourth stage of the petroleum industry is transportation. In this stage, the petroleum is transported from the production site. This can be done in several ways, by road, rail, sea, or pipeline. Pipelines can be thousands of meters long and are typically made from steel with an average diameter of anywhere between 10 to 120 centimeters. The oil is kept in a constant motion by regular pump stations along the pipeline and flows on average at speeds of up to 6 meters a second. The oil's final destination is the refinery, where the last stage of the petroleum industry takes place. The last stage of the petroleum industry is refining. Petroleum essentially is useless in its natural state. What's valuable and useful are the various components that make it up. These components all have different molecular weights, and therefore have different boiling points. Petroleum companies take advantage of these different boiling points, and use them in order to separate the different components.
Petroleum is a non-renewable resource, so will not last forever. It is estimated that the Earth's oil supply will finally run dry towards the end of the century. When that time comes, mankind will be forced to resort to a new source of energy, such as solar or geothermal. But for now at least, petroleum is essentially what makes the human world go round.